morning, my name is Silvia Carvajal.
My name is Carolina Rios.
Today we're going to present about momentum part 2, which divides into elastic and inelastic collisions.
And the definition for momentum is the quantity of motion of a moving body measured as the product of its mass and velocity.
So there are two different types of collisions. One is elastic collision, which is that the kinetic energy and the momentum are conserved. And for inelastic collisions, the kinetic energy is lost, but the momentum is conserved.
So then for this, we're going to have like a little experiment for explaining a little bit more about elastic and inelastic collisions. So come here. So we have two balls with different masses, and the first ball will be the elastic collisions. The first ball is stationary, and the next one will be like collide with the second one. There was like in this part was the transfer of momentum and kinetic energy.
Okay, so for inelastic collision, there's no experiment done on Earth that can prove that in an inelastic collision, both of the balls, when they strike together, they move to the same direction in the same velocity, except in space because of the force of gravity.
So the formula for an elastic collision is m1 v1 naught plus m2 v2 naught equals m1 plus m2 times v final. And also we can calculate the initial kinetic energy, and the formula is kinetic energy final over kinetic energy initial equals m1 over m1 plus m2 times 100%.
So we're going to give you an example for inelastic collision, and it says a 3 kilogram ball with a speed of 6.5 meters per second strikes a 4 kilogram stationary ball. If the collision is completely inelastic, A, what are the speeds of the balls after the collision? Letter B, what percent of the initial kinetic energy do they have after the collision?
So before to get started and make like the result of the problem, we're going to have like a given, and the mass 1 is equals to 3 kilograms. The velocity of this object is v1 naught, and it is 6.5 meters per second. And the second mass is 4 kilograms. And the problem says that this mass is stationary, so the velocity of this object is 0. I already gave you the formula for the inelastic collisions, and it was m1 v1 naught plus m2 v2 naught equals m1 plus m2 times v final. So if we already know that the velocity of the second object is 0, so we can cancel this, and we get m1 plus v1 naught equals m1 plus m2. And later v final. And later A asks us for the final velocity, so we like move m1 plus m2 for it already for v final. So v final is equals to m1 v1 naught over m1 plus m2. So we can just plug in the values, and we have v final is equals to our mass 1, that is 3 kilograms, and our velocity is 6.5 meters per second over our mass 1, that is 3 kilograms, times plus 4. And this is equals to 6.5 times 3, 19.5 seconds over 7. divided, and we get for B final 2.78. That can be also 2.8 meters per second. And we have the letter B that asks us for the kinetic energy initial of the object, and we can calculate with kinetic energy initial over kinetic final over initial, that is equals with m1 over m1 plus m2 times 100%. So we can also plug in the values. That is 3 over 7 times 100%. And we get 42%. And it is our final answers for this problem.
Okay, now we're going to show you an example for an elastic collision. For the elastic collision, we have two formulas, which is to find B1 and B2. For B1, we're going to use M1 minus M2 over M1 plus M2 times B1 naught. And then for B2, we're going to find 2M1 over M1 plus M2 and all of that times B1 naught. So
we have an example for this problem, and it says a 1.2 kilograms object with a speed of 6 meters times seconds in the positive x direction has a head-on elastic collision with a stationary object of 3 kilograms that is also located at x equals 0. What is the distance separating the objects at 4 seconds after the collision?
okay, so like she said, the second mass is going to be stationary, which means that it's not going to have any velocity, so it's 0 meters per second. And we're going to find B1 and B2 with those formulas. So for B1, we have mass 1, which is 1.2 kilograms, minus mass 2, which is 3 kilograms, over the same thing, but now we're going to add them. Times B1 naught, which is 6 meters per second. And we're going to get, for B1, we're going to get negative 2.6 meters per second. And now for B2, we're going to do 2 times mass 1, which is 1.2 again, over mass 1 plus mass 2, so 1.2 kilograms, plus 3 kilograms, times B1 naught, which is 6 meters per second, and we're going to get 3.4. And those are our final answers for velocity. Now we're going to find the displacement of both of the objects in a time interval of 4 seconds after the collision. And for that, we're going to use the formula x equals v times c. And we're going to, for the velocity, we're going to use the final velocities that we got in the previous video. So for x1, we're going to have negative 2.6 meters per second times the 4 seconds that they gave us, and it's going to be negative 10.4 meters. Now for x2, we're going to use the second one, which was 3.4 meters per second times the 4 seconds, and we get 13.6. To find the change in x, so for change in x, it's x minus 2 minus x1. And then we already got them, so it's going to be 13.6 meters minus negative 10.4, which will give us a value of 24 meters. And that's our final answer.